Video got reduced and cut down due to technical difficulties. This is the second part of the gradient calculation, tangential gradient calculation video. So I was at 1D, and so I was trying to calculate the. So I picked out these 2 points, and now I was trying to calculate the gradient. So it'll be 30 over 23. So that's the equation. The gradient 30 over 23x plus c. Now if I wanted to calculate the c, it would be, I'd take this one here and put, half equals minus 1 c. There we go. So yep, 1 whole 3 over 4. And 210 over 80 is 92. So that will be the gradient, minus 1.783. So the final equation would be, Now I've done one example of how to calculate gradient of tangential points, tangential gradients on a curve. I won't be doing these 3 because they're the same formula, same caliber. I'd move on to this one. I'd do one example of this, so I'll do this now. Bear in mind, it'll be easier to calculate for this point. Sorry, it should be like this. And it'll be easier for this point, then it'll be for this, because this is really tricky. You'll have to have good geometric skills to be able to calculate that. So just bear in mind, if the examiner, usually the examiner will give you something like this, these points here, but rarely you get this, because if you do, then your geometric drawing skills have to come into play, and you have to make sure the line doesn't touch the curve, because the curve here is almost linear, so you have to practice it multiple times. So if you've got a curve here and it asks you to calculate the point here, make sure the curve doesn't touch the line, and then you can pick a point here, calculate the gradients. Now I think that's quite self-explanatory. I'll move over to this example of 4 and 4.4, and I'll calculate the tangential lines here, because the circle is quite easy, it's quite broad, and on a circle the probability of touching the line is very rare. So if the point is here, I can easily draw it like that, or like that, yeah, like this, most probably like this. And then if the point is here, then I'll draw a line like this. It'll be quite easy to calculate the line, the gradient. So now we'll start off with the first example, question number 8. We'll do question number 8. And one more point, make sure in the exam when you're drawing the line, you use a blue or a red or a different colored pen when you're drawing, because so that you can differentiate between the line and the curve, because a lot of students with visual dissonance difficulties and disabilities will get confused, and it'll lead to a wastage of time. Okay, so I'll do one of this example and one this. So I'll pick out the points for these three, and then we'll take it from there. So for 8A, I drew a line at 3 and 4, and I found these two coordinates, and I'll be taking it from here. So it has to be 5.25, 2 and 5, and then 5.25 and 2. So it'll be it's minus. I'll ignore the 0 for now, but it is minus 2.5, 0.25. Okay, so moving on to this line. We'll get the coordinate 3.25 and 4, minus 4. 3.25 minus 4. And then for this one, we do what, minus 1.75. And 5. So for D at 4 and minus 3, the coordinates are first one, so 5 and minus 1 point, yeah, so 5 and minus 1.75. So this is how we'll calculate the gradient. The gradient would be modulus, and these two lines stand for modulus. So I'll take these two coordinates, and then so y's, and it'll be over so that'll be minus 4 and point, so that'll be 2.25 over 1.75, and that'll be 9 over 4, so that's 4, so 7 over 4, so 7 over 4, so 9 over 7, that'll be the gradient, plus, so it'll be the gradient, 9 over 7, so that'll be the gradient. So we conclude this small exercise that's quite lucrative in terms of getting easy marks, but your geometry has to be on point. You have to learn geometric drawing. You have to learn to draw tangents quite accurately and only approximate to a limited extent. So that's how you'd calculate the gradients. And every single time when you're about to start the calculation, you have to start from this m modulus delta y over delta x equals y2 minus y1 over x2 minus x1, and then you put in the coordinates. You take the second coordinates, the second set of coordinates goes first, and the second coordinates goes second. So the second coordinate group goes first, and the first group goes second. So y2 minus y1, x2 minus x1. That's how things are. And I hope you learned something today. I didn't do all the examples because of monotony and technical failure of my videography apparatus, but I hope you get the point, and I hope you learned something today. Now, let me clarify something. If you've got a graph here, and a line is going like this, the gradient will be positive, positive. If a line is going like this, or this, and this, and this, and this, it'll be negative. Now, negative gradient means, what is negative gradient? Negative gradient is going from here to here, here to here, here to here, here to here. So these are all negatives. What's a positive gradient? Positive gradient is this. These are all positive. I hope you understand. Thank you very much for your patience, and I hope you learned something today. Have a lovely day. Take care. Bye now.